Hello and welcome. Hello. Hello and welcome back to another video. And you guys remember the last video in which I made a to-do list software, and what I was thinking about was making an explanation video for that. So what I did was I went into Google AI Studio, and with the help of Google AI Studio, I created this code explainer where you can actually visually understand the code. So you're actually going to be able to understand the code. And this is going to be really fun. This is the Flat Code Visualizer. Alright, so you can see this is the app over here. This is the screen for the app, to-do list software. You can actually do stuff in this. I'll tell you about that later. Everything's like visible, right? You can see everything. So first, the main thing is about understanding the code, right? Also, there's some execution history where you can see what code was executed for what part. And so let's get to it. So first we're gonna start with this. No, hold on. This is not it. This is the thing. This is it. Import flat as FT. I understood some really cool stuff with this. Alright, look. Alright, beginner flat developer. This is the first line, import flat as FT. It's being executed, and this is the explanation. Let's dive deep. What is this? Okay. Imagine Python's execution like a workshop, because before you can build your amazing flat app, you need to bring in the right tools and materials. Line 1 is import flat as FT, token by token breakdown. Import, what it is, it's a special Python keyword. Think of it as an instruction or a command. Its job, it tells Python go find a collection of pre-written code, a module or a library, and load it into my current program so I can use its functions, classes, and variables. It's like saying, hey, I need to build something, so bring me the specialized construction toolbox. What is flat? It is the name of the specific Python library or module. You can call it a Python library, you can call it a module, and we want to bring it in. Flat is the framework that allows us to build interactive user interfaces. Its job is to identify. What is the job for this flat? It identifies which toolbox to bring. The flat user interface building kit. For now, we need that. This is another Python keyword. As. Okay. Now we're talking, so we've done flat, now we're talking as. This is another Python keyword. It is used for aliasing. Its job is to, so we're talking about the as keyword. As is a keyword. What is as? Another Python keyword for aliasing. It gives you the imported module. Hold on, let me see. Alright, this is okay. Hold on. Alright, this is. Alright, this is okay. Okay, so this is another Python keyword. It tells you it lets you give the imported module a shorter, more convenient nickname, an alias to use in your code, making your code cleaner and saves typing. After bringing the Flat UI building kit toolbox, you decide it is too long to say every time. So you say, let's call this FT for short. What it is, it's the alias nickname we've chosen for the Flat module. Its job from this point forward, in your script, whenever you want to use something from the Flat library, like the page, text, column, you will refer to it using FT instead of Flat. This is the actual FT label you stick on your Flat UI building kit toolbox. What it does to memory. So what happens to the memory? So before it was import flat as FT, now it's gonna flat and FT are unknown. After import flood as FT, the namespace. Okay, I also have something visual. It's also showing the visual thing. So you see, this is the beautiful thing about Google AI Studio. It's so creative, like you can understand stuff. And now, okay, namespace. So this is the before part, and this is the after part. Now there is a namespace, current scope. Current scope is the namespace. Namespace is the current import. Namespace is the current scope. After import flood as FT. Import flood. Okay, so I noticed this thing that flood and FT are unknown. So afterwards, what happens is that it imports flood as FT, and as they're probably known. Okay, variable name value object. The variable name is FT, and flood value object, flood module object. It contains all flood classes, functions, etc. Okay, Python's interpreter goes out, finds the flood library files on your computer, and loads all its code, classes, functions, constants into memory. This creates a special module object that represents the entire flood library. Name binding. Python then creates a new name, a variable name called FT in your script's current working memory. It's namespace. What is namespace? Namespace is the current scope. And Python is going to create a new name called FT in the script's current working memory. It's namespace. I don't exactly know what that is right now. Okay. Current knowledge. Anyways, reference. This FT name is then bound or points to the flet module. You're going to easily understand that this is also pointing to the flet module somewhere in memory. It's pointing to the flet module object that was just loaded into memory. Exactly. FT is going to point to that module in memory. Now, whenever Python sees FT later in your code, it knows to look inside that loaded flet module object for whatever comes after the dot. What the user sees. Before we were looking at this, empty screen, nothing rendered. After, still an empty screen. This line prepares the tools, but doesn't build anything. The user interface remains unchanged. The import line does not directly change anything on the user screen. Indirect user interface preparation. Its effect on the user interface is entirely indirect. It is a foundational step. Running this line, you're simply making the necessary flet components and functionalities available in your Python script. You're bringing the blueprint and tools into your workshop. You still need to use those tools and blueprints in subsequent lines of code. So we still need to use them. We're not doing anything. We're just importing stuff. Empty.page to actually construct and display the user interface elements. In summary, import flet at FT is like opening your flet toolbox and labeling it FT. It is an essential first step. Setting up your environment, but the actual building and visual results come from the code you write after this line using the FT alias. Now let's go to this. Line number 3. Now you understand what import flet as FT does, right? It's really simple. Google AI Studio is helping us understand the code much better, deeply. Let's visualize this core line of flet application. Imagine your computer's memory as a vast set of labeled boxes, and use user interface as a blank digital canvas. The blueprint line, DEF to-do list, this line is not immediately drawing anything on your screen. Instead, it is like creating a detailed blueprint or a recipe card for a specific set of actions your program can perform. It tells Python, here's a new function, this is its name, and this is what kind of input it expects. Token by token breakdown. So DEF is a keyword. Think of this as a function definition. Okay, sticker. It's a special keyword in Python that signals what comes next is a new function I'm defining. Memory impact. Python starts preparing a dedicated block in memory to store the instructions that will belong to this new function. To-do list. This is the function name, the unique label, or a name tag for your blueprint. So you understand this is a name, it's a function name. for our blueprint, all right? It's a label, a name tag. It's the name for our blueprint. It is how you will call or execute. Hold on. Because Python is going to start preparing dedicated block in memory to store the instructions that will belong to this function. Okay, so that is why we're calling this a blueprint. Because it will contain all the instructions. This function will contain all the instructions, alright? That will be later performed, and that is why it is being called a blueprint. Anyways, this is how you will call or execute this specific set of instructions later. Because the instructions are inside this function. A named entry to-do list is created in Python memory, acting as a pointer to the location where the actual function's code, acting as a pointer. So that named entry is created, and that is going to act as a pointer to the location where the actual function's code, its blueprint, will be stored. Opening parentheses. This marks the beginning of the input specifications for your function. It is like the opening of a shopping list for ingredients the function will need. Memory impact signals the parser to expect parameter definitions. Now, what is page? Page is a parameter name. This is the placeholder name for a piece of data that will be given to the to-do list function when it is called. So this should clear so many doubts. This is a placeholder, alright? Why is it a placeholder? Because when we call the to-do list function afterwards, at the end or anywhere else, we're going to pass something into that function, and that something is going to be stored inside page. So page is a placeholder for something. It is like labeling an empty jar, page object. So you have a jar, you label it, put a paper on it, put some tape on it, and you write on top of the page that you stuck on the jar, you write page object. So it's an empty jar, but it has this sticker or label on it called page object. This page name will become a local variable within the to-do list function scope. Now this is interesting. I did not know that because I thought that the page would be like a global variable. But now I understand that this page name will be a local variable, and its scope will be its scope is only limited to the function and the name of the function to-do list within the to-do list function scope. When the function is executed, alright, it will become a local variable within to-do list function scope when the function is executed, holding whatever value is passed into it. Okay, next we have the colon, the two dots. The colon is a type hint separator. This is a type annotation connector. It connects the parameter name, which is page, to its expected data type. Its data type is ft.page. This object is of type ft.page. It's just a type. It's telling us this object is of type ft.page. It says this item in this jar. It says the item in this jar should be of this type. Okay, so you remember the jar we were talking about, right? So there's an empty jar, and whatever item we put in that jar, it should be of this type. And what type should that be? It should be of type ft.page. Primarily for developer readability and static analysis tools, does not change how Python executes the code at runtime, but provides useful information. ft.page. Oh, okay. So colon is a type hint separator. Type hint separator. But what is ft.page? ft.page is actually the type hint. Oh, okay. I was confusing these two. I was mixing up. So you can see over here that the colon over here is a type hint separator. It's separating the type hint. It's a type hint separator, so it's separating the type hint. And what is the type hint? The type hint is actually ft.page. This is the expected data type. So the page name is going to be of the expected data type of ft.page. So ft.page is the data type for the small page. You get that, right? Page is the name, and it has a data type of ft.page. So ft.page is data type for the page, the small page. Page with a small p. You'll get that once you start understanding. So, for the page parameter, this isn't. Now, what is ft? FT is an alias, a short nickname you've given to the flet library. Yeah, from import flet. Yeah, this is the attribute access operator. It means look inside FT for something named page. Yeah, we're looking inside FT, inside the flet module, for something named page with a capital P. This is a specific class. Now, what is page? Page with a capital P is a specific class or type defined within the flet library. I don't know why it's calling class, why it's calling page a type. I know it's a class. Why is it a type? And ft.pageObject is flet's representation of a single window. An ft.pageObject is flet's representation of a single window or screen in your application. It is your canvas. What happens to the memory? It declares that the page variable, when it exists, is expected. Declares that the page variable with a small p, when it exists, is expected. Hold on, memory. When it exists, is expected to hold the page variable with a small p array. It is expected to hold an instance. It is expected to hold an object of the ft.page class. All right. So yeah, the small. Let's read that again. We're talking about the page class with a capital P. It's a class, and the ft.page object is flet's representation. ft.page isn't the object we're talking about. I think this is talking about the page with the small p. This page. This is the object of this class, because we create objects of classes, so this whole thing is a class, and then the page with a small p, this is the object. So this is referring to this object. And this object is obviously going to be of type this. Page is an object belonging to this class. I hope you understood that. Yes, this simply means the same thing I've told you. Expected to hold an instance. It declares that a page variable, which is an object, a parameter, you can call it, whenever it starts existing, it is expected to hold an instance of the ft page class. I get that. It is going to hold something which is of type ft.page. Closing parenthesis, this marks the end of the input specifications. You're done listing what the function needs. The function needs all these things. Memory impact completes the parameter definition. Function body separator. Now what is colon at the end? After the bracket. After the parenthesis. Closing parenthesis. This is the body start indicator. This is the body start indicator. This is the body start indicator. Alright, you're done listing what the function needs. Memory impact completes the perimeter. Okay. So the colon at the end is a function body separator. This is the body start indicator. So we're talking about the colon after the parentheses. After parentheses. That's the colon we were talking about. What is that? What the function does. Yeah, this is the colon after the brackets. It is the function body separator. This is the body start indicator. It's like saying now everything that's indented on the next lines belongs inside this to-do list blueprint. So whatever comes after this colon belongs to this function. Simple. It's a function body separator. The colon is a function body separator. That's a function body, and that's the function, and this is going to be the body of the function. So it's a function body separator. I get it. Python knows that all subsequent indented lines define the actual code instructions for the to-do list. Yeah, all the instructions. A new function object named, okay, what happens next? A new function object named to-do list is created and stored in your memory's program's memory. This object encapsulates the instructions that will follow. The definition includes a placeholder page, yeah, the small p, and an expected type, yeah, no immediate data flow or changes to variables yet, as the function is only defined, not called. This line is purely a definition. The user sees absolutely nothing on the screen at this point. The to-do list function will later be called by this, and then the page object will be passed in, and its internal code will start building the user interface. The page object will be passed over here. Actually, the page object has not been passed. Only the function is called. Page object is passed over here. I think maybe that it does that internally. So this line is just setting up how to build it. And now we move to page.window.width is equal to 400. It's really simple. Think of your flat application as a play happening on a stage. The page is the main stage itself. So this page is the important thing with a small p, the object. And the window is the frame that holds the stage. Oh wow, that is so cool. So the page is the main stage itself, alright? And the window is the frame that holds the stage. You get that, right? The frame that is holding the stage. Controlling its physical dimensions on the user's screen. Imagine this line as giving a very specific instruction about the outer container of your app. Okay. Now, let's start with page. This refers to the main ft.page object, which is like the core content area, or the canvas of your application. Everything you see and interact with inside your app lives on this page. It is the central hub. A variable named page holds a reference. A variable named page holds a reference to this ft.page object in your computer's memory. Why is there a dot operator? This is like saying look inside or access a part of it. It connects the page object to one of its specific attributes or components window. Okay, so what is window? This is an attribute of the page object. It is not the window itself, but rather a special object that holds all the configurable settings and properties related to the physical operating system window. It's not the window itself. You understand that, right? It's a special object itself. For a browser tab that contains it. Okay, think of it as the window settings manager. Python retrieves the window settings object. Python retrieves the window settings object that belongs to your page. Now we're at this dot after the window. Look inside operator, yeah. Dot operator. Now we're drilling down further, looking inside the window settings object. Width. What is width? This is an attribute of the window settings object. Specifically, it is the property that controls the horizontal dimension, how wide it is of the application window measured in pixels. Python identifies the width attribute within the window settings object. And now we have an assignment operator. This is the assign value operator. It takes the value on its right side and stores it into the variable or attribute on its left side. 400. It's an integer literal representing the number 400. In this context, it means 400 pixels. The integer value 400 is stored in the width attribute of the window object. Wow. The integer value 400 is stored in the width attribute of the window object, which is part of the page object, yeah. So this is the visualization. This is the page object. Page points here. And then we have the window settings object. It is accessed via the page.window. Wow, this is actually so interesting, so in depth, and I understand every part of the code. This is the window settings object. How do we access that? Page.window. So inside, go into page, and then access window from there. Page.window, right? Access window, which is sitting inside page. Access window. Go inside page and access window. Page.window. And now we have width. 400. Value assigned here. What the user sees when your flat application starts and renders, this line of code directly influences the initial appearance of the application window. The application window that pops up on the user's screen will be set to 400 pixels wide, a visual constraint. No matter what content you put inside the outer frame, the window will initially adopt this width. You get this story as well, it says the same thing. Now we have page.horizontal alignment center. Imagine your flat page as a blank canvas or a whiteboard where you're going to stick your app's component. Think of it. This is your main ft.page object. Think of it as the entire visible window or canvas of your flat application. It is a top-level container for everything you display. Page is a variable that holds a reference to ft.page object, which exists in your program's memory. You need to understand this part. Page is a variable. It's just a variable that holds a reference to a ft.page object. It's referring to an object that is of type this, and that object exists in memory. So this thing is pointing to that object in memory. And it is of type this. This object has many configurable properties: width, height, alignment. Now this is the visual stuff. This is your app window. This is the page object. Then we have the dot operator. This is the member access operator. It's like saying go inside the page object and find one of its specific properties or settings. It instructs Python to look up for an attribute, a piece of data, or a setting within the page object. Think of it as opening up a control panel for your page. Accessing pages settings. Okay. This is a specific property. Now we're learning about the horizontal alignment, a specific property, an attribute of the ft.page object. It dictates how the controls you add directly to the page using page.add will be positioned horizontally within the page's content area. It refers to a specific slot or variable inside the page object's data structure that stores its horizontal alignment preference. Imagine a dial or a setting switch on your page's control panel, specifically for horizontal positioning. Yeah. And then obviously the assignment operator, we know what that is. It takes a value on its right, and which is center in this case, and stores it into the property on its left. It updates the value of the horizontal alignment attribute within the page object in memory. This is the action of setting. The dial or flipping the switch. Okay, page horizontal, we're changing the setting. What is center? A string literal, a piece of text data. Specific value you want to assign to horizontal alignment. Flat understands center to mean position elements in the middle horizontally. Other common values might be start left or end right. This string value is temporarily created and stored into the attribute. What it does to memory. The page object, which represents your application window, has an internal property named horizontal alignment. This line changes the value of that horizontal alignment property from its default, usually start. Oh yeah, that's true. Which means left aligned to the string center. And whenever Flat needs to decide how to horizontally place its top level control, they add directly to your page. But look at this. Before this line or the default alignment, if you were to add controls directly to the page, they would typically align to the left side of the window. Yeah. After this line, any controls you add using page.add, like your ft.text and the ft.row containing text field, will be automatically placed in a horizontal center. This setting applies to the top level items you add to the page. Alright, now we move to line number 9. Imagine your Python program as a busy office, with memory being a large file and cabinet, and user interface being the whiteboard on the wall. Okay, tasks, this is the variable name. Think of it like a unique label or a named folder. In Python, we create variables to store and refer to pieces of data, telling us it is intended to hold our tasks. We know what the assign operator is. Assign the value on the right-hand side to the variable name on the left-hand side. Now what is this? What is what we want to actually focus on? This is an empty list literal. In Python, square brackets are used to define a list. When the brackets are empty, it means create a brand new empty list object in memory. A Python list is a fundamental data structure, an ordered, changeable collection of items like a shopping list or a series of to-do items. It can hold any type of data. This line performs two key actions in your program's memory. It creates an empty list object. Python first processes this. It allocates a small chunk of your computer's memory to create a new list object. This list is initially completely empty. It has no items inside it. Next, the operator takes the newly created empty list object and makes the task's variable name refer to it. Empty list object is on the right and makes the task variable name refer to it. It's talking about the specific empty list box. It's currently empty. It points to all the items you'll add. I haven't written anything unrelated to anyone yet. And call. But we'll read this from this task list too. So yeah, you get the idea, right? So I'm just gonna browse through the text. You can read it yourself. Right? It's not. Yeah, I'm just gonna like read it. You can read it as well. Constructor call. To the variable name on its left. What is ft.column? You know that ft is the alias. Yeah. Here it comes. Here. Okay, looking. Now look at this column class proud of it flat. When you see a class name followed by parentheses, you're telling Python, create a new object of this column class. A new variable called task list. And it's creating a computer memory. Objects created. The task list variable now holds a reference to the newly created object. From now on, whenever you use task list encoder and interacting with that specific column object. So an object was created for this class, and then task list is going to point to that object. So it's pretty simple. task list. Okay, see that column object. So I hope you understood that. It's pretty simple. Now let's move on to the next function. Update task list. Alright, so imagine your writing start recipe here on a blank card. Yeah, we know defined as a keyword, short for define. Function prepares allocated chunk of memory to store a function object. All the instructions, this object will contain all the instructions. Internal declaration for Python. Identifier. Okay, a name chosen by you. Python takes a function object or prepared and associates this name of the task list with it for this specific set of instructions. It's just all of this is just an internal setup. Ingredients needed for this step. Since they're empty, it means this function does not need any specific data passed directly into it to do its job. It will rely on variables that are already available in its surrounding scope. Task and task list. You draw a thick line or a start instructions here mark right after the recipe title. Update the page. This line defines what update task list means. And then we have this task list that controls that clear. This is what I'm going to study. As a physical to-do list column on your screen. Inside this column, there's a dedicated shelf labeled controls, where all the individual task items are placed. Python variable in our code. It holds a reference to an object if let's ft.column control. Attribute property of the column object. Okay, I have the column object. Task list. Standard Python list, specifically designed by Flet to hold other Flet controls. The task list, the column, should display as its children. Flet control, in our case, for our objects. Task is referred to delete button. This control list defines what appears inside the task list column as a screen. All elements from it becomes, okay, empty. All the references from the controls list. So that object still exists, but its internal list of children is now empty. Alright, now it's time for this. We are on line number 14. IDX and task are the loop variables, or target variables. Alright, let's move to line number 16. Alright, it's time for controls. So this is really easy stuff, it's not that hard to understand. So most of the code is like self-explainable. So you've understood this part. So this is gonna check if this is empty or not. If it is if it's empty, it's not gonna do anything. But if it's not empty, if there's text in it, it's going to do something. What is that? It is going to it is going to append whatever stuff it has, whatever text it has stored inside task input, right? It's going to pass that over here and this append. So what's this going to do is whatever text the user typed, it's going to be attached. We're going to see it over here. We're going to see it over here. You can see it. See this? Then task input would be buy milk. Append. What is append gonna do? Look at this. It's gonna place the value, whatever text the user type, and place it at the very end of the tasks list. So whatever happens, I type something at number one, it comes at this, and then I type something else at number two, it comes under that. And if I type something else, number three comes under that. So it's gonna append at the very end, and then it's going to clear the input field like this. I type something, it's gonna clear the input field. You see, when it comes here, it clears the input field. And then update task list. You gotta study this. It's the function call, yeah. Process into flat controls. Your raw data is read, which is a task list. It is then processed into f2.row controls, which is the row, the horizontal thing. It's sent into this and then stored inside the task list. So all that data is inside the task list. And then we call page update to render whatever stuff that the user has typed and displayed over here. Data list and memory. And finally, you have delete task. So let's try to understand this. So if I press delete here, you see these three functions, they ran. I mean, this single function ran, and all the instructions inside it also got executed, and then page.update got executed to update. It's really simple. Clear deleting a task. Okay, what is IDX? An input slot. When someone calls delete task, they must provide a value for IDX. This IDX will hold a value that was passed. If you call delete task 3, IDX will be 3. You get that, right? The current index number. So whatever task is at that current index number, that task is going to be deleted. So you get the idea. Now it has to pop. So you can see buy milk is at 0, walk dog is at 1, learn flat is at 2, internal numbering, Python internal numbering. So idx minus 1, look, this is the variable. That doesn't pass to the pop method. On the screen we see 1, 2, and 3, but on the Python's indexing thing, I think that's 0, 1, and 2, right? Yeah, Python internal numbering, 0, 1, 2. Python lists a 0 index, Python lists. First item has 0, 0. So that means if it's the first element, so index is 0, right? Hold it. Hold it, hold it, hold it. So for example, user clicks on remove on 2. 2 minus 1, this is the actual index Python needs. Walk dog. Oh, I get it. So it's very simple. So for example, hello is at first, and then walk dog. So walk dog is gonna be on the second, right? Walk dog. This is what we see. But the index number is 0, 1. The index number is 1. So index number should be 1. How do we tell Python that you need to delete this? Right? Look. Come on now. Hurry up. One base for you need to subtract 1 to get the correct zero base index. So like what I understand from this is that, for example, if we want to delete walk dog, we're gonna have to pass 2 into this. So 2 minus 1 is equal to 1. So if we look at Python indexing 0, 1, at 1 we have walk dog. This is what I understand from this. So get the correct zero base index. Okay. Now the pop method receives the index 2. It looks at its hash and finds the item at index 2. Human index this. Okay, so 3 minus 1 becomes 2. 3 goes into the calculator with 1, and the output is 2. So you get the idea, right? You can calculate this on your own. And then this method is called update task list, which is this. It updates everything, and you can see the remove icon is also here. And whatever you want to remove, it gets removed, and it updates the task list and then updates the page. And finally, you know what this is. This is the main function to-do list. It gets passed into this, and then when it gets passed into this, the flood application is run. So it's basically running from here. But we need to pass it into this to start it. So you get the idea, and this is the execution history. So for example, if I do delete, hold it, let me do it again. So look at this. I deleted that thing, and all these 3 lines ran, and then page update ran. If I look at the execution history, this is the execution history. This is delete task IDX, which is this. Then we have task.pop, which is, hold on, task.pop is over here. You see this? Then after task.pop, this is a line update task list, which is this. And what else do we have? And then page.update, which is this. Look, page.update, which is this. So this also shows the execution history. Thank you. Thanks to Google AI Studio, you can literally make whatever you want. You tell it to. So I also have the execution history in this, so hopefully you understood the program. This was the to-do list, a simple to-do list in Python, a simple software. A simple software that adds and removes tasks. You can add them and remove them. And this is completely in Python, and I've used a framework which is known as Flet. Flet is a framework, and this whole thing is in Python. So this is a simple to-do list in Python. A simple to-do list in Python using the Flet framework. So thank you so much for watching the video, and I'll see you in the next one. Bye-bye.